Hello, everyone. Welcome to another Wolfram Language Design Review for version 14.3. Getting towards the end of the version 14.3 cycle. We are looking right now at control and system modeling, control theory and system modeling. Okay, so
I don't know which order you want to do it. In a way, the control part is probably small, so maybe we should
let's look
start
at
there,
that first. Let's look at
and
that.
then we can dive into this, which I'm sure will lead to much more discussion.
Okay.
So, as I said, sort of as a preamble, it's really optimizing workflows and some fill-in functionality, and this is a missing function. This is a standard item that you often do when you look at filters in control systems, linear systems. You look at the locations of poles and zeros, and from that location, you can say something about how fast the system is going to behave. And these illustrations need some call outs, but
I'm surprised that that's an ellipse rather than a circle. I thought it was
it
usually
should be a
a
circle. This is incorrect. It's using the wrong aspect ratio.
Yeah, it will be fixed. Yes, the updated
It should be a
one,
unit circle.
It will be unit circle.
And there's O's and X's are like poles and zeros or something
So
like that?
X's is a pole and O is a zero. If there is a zero, that means something will be damped out.
Indeed. And if there's a pole, it means it won't.
Right. It's a mode that can be excited.
So what happens if I just type pole zero plot of just that function, 2 plus s over s, 4 plus s?
Suba?
I was muted. Yeah, it may work, but we support it at 1 point. But yeah, you can try pole zero plot 1 over s. Probably it may work, but not documented. Yeah, it works.
Why don't you document it?
This was an earlier design discussion. We didn't want to. We actually mentioned it in generalizations in the other functions that it works like that.
Is there a pole plot or
No.
not?
No.
No.
Okay.
Yeah, so this behavior is consistent with all our frequency, like Bode plot, Nyquist plot.
Yeah, but
all of
I
them.
don't understand. Why can't this just be a general system function, pole zero plot of any function?
I mean, it will not work in general, but we can make, we can support it and then fail when we fail.
What do you mean it won't work in general?
Because we can't compute it in general.
No, I understand, but if you have a polynomial function or something, you certainly can compute it.
Yes.
Yeah.
I mean,
and also the other thing is that for general, let's say a meromorphic function or something like that, there's usually can be a countably number pole, they're not finite. Same with zeros.
Yeah, sure.
Yeah, so over here also we have delay systems, and then we can give a region where we want to see the poles.
So delay system means you get exponential functions in there, in the rational function, and that means that you typically have an infinite number of poles.
Yeah, I get it. But so to me, what we should do, you can always give the region over which poles, I could say S from whatever it is. Now this is in the complex S plane, right?
Yes.
Yes.
So the analogous function, what is the analogous function for plotting?
Complex list plot. It's based on complex list plot.
No, but I want the function plot version.
Well, complex plot is such a thing. You have to give an S region. S,
Yeah, by the way, that error is wrong. Look at that error. That's wrong. It should just be a wrong number of arguments.
Right. That could someone capture and report?
Natalia, if nobody else. Yep. Okay. And is it in fact okay? So if I say
S min, comma S max, two complex numbers.
So I have to give the whole shebang like this.
Yeah, actually, there's a short form of it that's shorter that we added after, which is to give
just the range, right? It would just, if I say 2 or something here, it'll just do that.
Right. That's a short form of it.
Yeah, right. But so that error message should also be fixed for that. But okay. So I don't quite know why there's such a dark black border around this. Doesn't seem quite right. Small comment, but we might as well look at it. Okay, but so to me, therefore, you know, I mean, I would love to see the same thing work, just work here for pole zero plot.
Yeah, so
Doesn't have
that's
to be hidden away. Go ahead.
that's the third argument. So
No, but that's not going to work. We need it to be the second argument so that it actually works like this. So we're not just making it an obscure control systems function.
yeah, if you look at the use, yeah, so we
I
use
know,
the
I looked at it already. We're not going to, that this doesn't make sense, right? That's the pole type and the zero type, right?
Yeah.
And what kinds of values can they have?
Yeah, right now it's not a transfer function, but when we support
For the
more
future,
functions,
Stephen, in general, there will be a matrix there. And then the question is, what is a zero of a matrix?
A
Okay,
matrix
it's
where? In the first argument?
in the first argument. In general, a transfer function model can be a matrix of transfer functions.
Yep.
And there are many definitions of what is a zero and what is a pole in those cases.
Okay.
So that's
Great.
what that's, you know,
That's
intended.
a good third argument or an option. Because presumably there's a good default, especially given that we have a symbolic representation of the transfer function. So I really think we should make this a mainstream function that, yes, it'll support all sorts of control system stuff, but also it should just support. I mean, I'm kind of wondering whether complex plot should support the control system objects. Should it?
Which one?
Well, I mean,
complex plot?
Complex plot.
Probably.
Why not?
I mean, there's no.
yeah,
it
but
doesn't.
you can do it in an indirect way now. You can ask for the
I don't
exploit.
care. Why don't we just make it just work?
Well, we can, but what I'm saying is it doesn't have it's a scoped variable in that case. It doesn't have an S.
No, I understand.
I mean, there is
It's
an S,
transfer
but it's like
model.
function has an S.
Yeah, I understand. But so just like we say S comma 2 here,
Mm-hmm.
right? Rather than giving the explicit thing, I'm saying we could have maybe we can have a one argument form of complex plot that just plots the transfer function.
Mm-hmm.
I mean, let me try it. If I take this thing, that's a transfer function, right?
Mm-hmm.
Yes.
And now I say complex plot, how do I get out the transfer function there?
You can either give it an, yeah.
No, don't tell me either. Just tell me one way to do it.
Yeah, just give it an argument S.
Here.
Yes.
That wasn't very exciting. How can that be right?
That's not right.
It's not right. Yeah.
Make a rep and evaluate around it. I don't know exactly what's happening. Just to be sure that it actually does something. I just don't believe that.
No, it's wrong. It's obviously wrong. So let's get out the function here. Oh, it's got, well, 2 levels of list, but why would the hell complex plot care about that?
Don't know, but
well, it's just wrong.
Just get it out and see what the heck happens, though. Yeah, good.
Okay, so there's a bug in complex plot when it's given lists. Does that make sense?
Yeah.
Yeah.
So somebody needs to deal with that. But to me, I don't understand why this wouldn't be a lovely thing to have complex plot be able to deal with the transfer function here.
Mm-hmm.
And then for pole zero plot to be able to deal with just an arbitrary complex function.
Mm-hmm.
Just seems like a fine, useful thing. Now, this unit circle here, what is that?
For discrete time systems, because that's the stability boundary. And the stability boundary for continuous time systems is the imaginary axis.
Okay.
Because these are systems, that means that they get input and they produce output. So a filter, it gets an input function and produces an output functions.
Right.
But they're called signals in this context.
Yeah. I have some vague understanding of this.
Okay.
Okay. So, I mean, we just need to make sure that this stuff.
And that's what those illustrations show. How
Right.
these
So how do we
systems-
specify the bounded region for a thing with an infinite number of poles?
Yeah, we explained it right there, including in the cell below, like rectangle, disk. In the cell right below that.
Okay. So this is not the right way to do it. Right? We should be doing it the same way that every other plotting function works.
That
So
means
for example,
flip the
it's a
order.
fine thing. Yeah, it's a fine thing to say pole 0 plot. I mean, if we say pole 0 plot 1 over s plus 1, oops. I mean, I guess we sort of S element of disk, we're kind of smooshing.
We're kind of
with complex
abusing, but there is
geometry.
another case where we do that, which is contour integrate.
I see. Where we're kind of having the geometry be as if real.
Yes. But
I think it
there
makes
it's
sense.
also very different in the sense that we are trying to get the boundary of that. So that's another special, you know. So contour, you're going to follow a curve, right?
Yeah.
A
I
contour.
don't see any problem with doing this. This seems very reasonable to me.
Mhm.
Probably just disk work, but as element of disk, I don't think I support that yet.
Well, because you don't need the S normally, you know, and we can do pole 0 plots for state space models too.
Yeah,
Yeah, okay. But so fine. So I mean, yes, you don't need the S unless you need the S. I mean, right? And if you have an encapsulated object like this, you don't need the S outside, presumably at all.
Right.
yeah.
Although you should be able to do this because you should be able to say plot it over this region. I mean, it can figure out the region automatically, but okay. All right. So graphically, can you give me a function that has a bunch more poles? Well, here, let me put in a pole.
If you pick something, if you look at the examples down there should be some delay systems. You just copy one
Well, I'm
example.
just going to say this.
I'm sure it's not going to work.
Why not?
Well, we'll see.
How do I do the range here?
Well, it's not supported right now.
Yes, it is. You've got preg, zreg.
Yeah, so then you just do automatic in the second argument.
Yeah. Why we have a different region for the poles and zeros, I haven't a clue.
That
Yeah,
doesn't
and then
seem
you
right.
can yeah, maybe you can just give disk.
Yeah, I don't see any reason to have a different.
Yeah, so it tries to convert that into a transfer function model to compute the.
Okay, so you need to make this just work, you know, with the math, so to speak, without it diving into control theory. Make sense?
Yeah. Mm-hmm.
But
Okay.
the key use case is not what you're saying, right? The key use case, and where it's a standard item, is for signal processing and control.
I agree, which is beautiful. I'm all in favor of it. Okay. So let's flip around these things, and I don't understand why preg and zreg have to be separate.
That doesn't make sense. Does it make sense,
Okay.
Suba? Why would we do that?
Yeah, we want poles in this, but if you just give one, it uses the same.
No,
for
just answer the question. Why would you ever want to have a different region to show the poles and zeros? I can't think of a reason.
Yeah.
So let's not do it because it's really confusing.
Okay.
Yeah, let's not do that.
Okay. Now, p-type, z-type, what are those?
That's the thing which I think maybe should migrate into an option when we can support it. Right now, there's nothing happening there. And this is what I say. When you have a matrix of functions.
I see how it's interpreted.
Right.
Well, let's cross that bridge when we come to it. Right now, it's a 2-argument function or 1 or 2-argument function, the second argument being the region.
Right.
Make sense?
Okay. Yes. Mm-hmm.
Nice function, though.
Yes.
Yes, it has nice
and
it's
just made, you know, the problem is that so we tried to fake it with existing functionality, and it just made the examples be very.
Yeah. Okay.
You know,
so just
to program it every
can
time.
I make a non-trivial? Can I make a complicated one? Is there something where I can make?
Yeah, there should be. Go look at one that has
scope.
delays in it, because they always have infinitely many of them.
Because it's
where are they, Suba?
They all like minimize those sections. So if you
where scope or
yeah, scope this
scope.
application.
Let's look at scope. Where is it? Or just scroll down. There should be something much more complicated.
The one with delays. that we show the region.
Okay. So now here, you don't need to say transfer function, right?
No.
Yeah, we can just say automatic. Yeah, okay. Yeah,
We're not saying automatic at all. We're not doing anything.
Yeah, in the new
Just-
design, we will not. Yes.
Yeah, okay. All right, fine.
Yeah, so here we have to specify what region because there are
Why?
infinite.
Why? Why?
Because there's an infinite number of them.
Okay, fine. But why don't we pick a, plot range arrow automatic? Surely we can do that. Be sensible. Think how to do it.
Well, we need to think about it.
Yeah, I mean, I would say, let me think.
I think it needs to issue a warning.
Fine.
Unless it's a
I think
rational
it's a good
function,
idea.
I think it needs to issue a warning.
Great. That sounds reasonable. And then what I would do is plot.
And I think
Something
that the
with a
automatic
dozen-
is perfect for the rational function because there we can sort of do everything. And if we don't do everything, I think we need to issue a warning.
Okay, so look, I've got a suggestion. Plot range all, I don't know why it needs plot range all here. It shouldn't, right? You just gave it the region. So don't use
I
plot range
don't
all.
know either. Why is that?
Yeah, because that option gets passed to complex list plot.
Okay,
But
we don't care. You'll deal with that. We don't need plot range all. If you gave the region, you've given the region. Period.
Yep.
End of story, right?
Yes.
Okay.
Okay, so the question for the rational function, I would have thought we want a default of plot range to automatic. If there's an outlier, we don't want to plot it. But plot range all,
No, if the outlier is for continuous time, if it's in the right of plane, we would want to plot it because
Absolutely. Disastrous.
all right, okay, fine. All
Fucking
right,
thing
so
will
plot range,
explode.
hold on. So let's go through the heuristics. In the case of pole zero plot, where it's just a naked function,
Mhm.
right? That's case number one. We'll talk about that in a minute. Case number two is where you have an explicit transfer function. In the explicit transfer function, plot range automatic should plot all the poles if it can, right? For a rational function, it plots all the poles. Do we
Right.
agree?
Yes.
Okay, for a non-rational function, for a transcendental function, it will plot a dozen poles, let's say, or something, or some. I think what it should do is go out.
I think that
Yeah,
we
go ahead.
probably need something much simpler as a first heuristic. And it should include, the imaginary line for continuous time systems, because that's that's absolutely critical to know what's the behavior is around that.
So you mean the imaginary axis?
Yeah.
Right. I mean, in this case, I don't really like the fact that it's all smooshed up on those,
I don't either. I think that's
these need to be more extended.
Yes.
I mean, there might even be an argument, I don't know the field well enough, but to put the imaginary axis in the center.
Yeah.
As the default.
Maybe in the center, but at least it should not be
right
just
at the edge.
Right.
Where you don't know whether there's anything coming after it.
Exactly.
Okay, so some heuristics for where to place those things. And I agree with you, a message saying something like there are infinite number of poles, in this case, showing.
Specify the region to be,
Well, it can just say, it could just say there are infinite number of poles in this case. It's going to show you something, and it's obvious that there aren't an infinite number there.
Mhm.
Okay. In terms of the visuals of the zeros and the X's,
Mhm.
I mean, that's a nice convention. Obviously, the X's are slightly stronger visually than the O's are. Is that?
And those are the, more important, to be honest.
Yeah. Okay. Well, fine.
Okay,
That's what I would assume too.
Yeah,
So-
so they're controlled by pole zero markers. That's been there since version 8. So even on root locus plot, this is the style we use.
So there is another plot that is called a root locus plot that was introduced many versions ago. And it shows basically how the poles migrate when you tweak a parameter, when you vary a linear parameter.
Is this something we could use in general?
Yeah, so I just came up, and I think we're going to want to work on that for the next release to make it more generally usable.
Sounds cool. I mean, that sounds cool. I can imagine doing that for the solution of a generic polynomial equation or something.
Right,
Mhm.
algebraic
Really nice.
functions, for instance.
Yes, seems really nice actually.
Right.
Because that's the quintessential thing you want to show in a manipulate with polynomial roots and things.
Yeah. No, this thing is not manipulating. It shows literally the whole,
No, I realize
parameter
that.
suite.
I know that, but
Okay.
imagine doing this for a generic polynomial. The roots of a generic polynomial seems very nice.
Right, with some parameter in it.
Yeah.
Okay, so
I
you have
mean,
a univariate polynomial, and then you have a parameter.
Yeah, I mean, I think
Yeah.
that the way this would work is I mean, clearly this is the parameter value, and I don't know exactly where the depending on
Yeah,
what the argument structure is. Probably we could put in a third argument as the second element here, which gives the essentially independent variable for this inside this polynomial.
So the independent variable is the k. Everything else is locked up in an equation.
I see, but don't you have to say what the variable of the equation is?
Well, not when we have transfer.
No,
you
I
would.
understand. Yes,
Yeah.
but that's why I'm saying you could give
Yeah,
that as
I
a
got
second
it.
argument.
Mhm.
That would be a really nice thing to have. I mean, it's great when we can leverage the control system's functionality and make it of general relevance in sort of complex analysis and so on. Is there anything else along those lines that we could do that with?
I mean, I think we do, and maybe we should for Bode plot too, which is to plot basically Fourier transforms. It's a correct, it's a useful way of plotting Fourier transforms.
I wouldn't know it. I only know it as Bode plot, but it's that sounds interesting. Maybe it needs.
And so that shows the
name.
magnitude and then the phase. Okay, so the up above one is the magnitude, the other one is the phase. And a typical thing that you do is what's called unwind or unroll the phase, so you don't get these discontinuities in the phase.
Mm-hmm. Okay, we should talk about that separately. Seems interesting. Why does this go so close to the top here?
Close to a singularity.
No. I'm asking graphically.
Padding wise.
Slot range padding.
Oh,
We should probably revisit these.
Yeah, I mean, I think there's new versions of this. Okay, anyway, that's nice. All right, what's
Okay, that was that. Then
what's this? There's
so this is the different ways that you can display a, so there is an attached cell that has various kinds of, there you go, there you see it. And those, you complained about that iconography.
Yeah.
And so we have Jeremy here. And so we could drill into that.
Okay.
What is that lollipop doing?
Yeah. So okay, so the one thing that came up last time, you said that we should click to, so the whole thing is designed consistent with what the other toolbars are already in the system, like image, mesh graphics. They all have like toolbars like this. And the behavior.
Sorry, what are you talking about? Look, this says change the appearance of the model. That's not right. It would be select the appearance, right? This is not changing. You might change or you might not change. You might just click the same thing again. This is, and presumably
it does change it actually. It does a convert.
No, I understand, but
oh no, maybe no. I take that back. This one doesn't change it. It changes the setting, which is the appearance setting.
Right, but I mean,
but that's.
I don't understand why this says model appearances, because that's wrong UX, right? This is an appearance that you are setting. You see what I'm saying?
Maybe I'm not following you.
Okay, this is a slightly subtle piece of UX design, right? I'm telling you, don't have a thing that says model appearances, which is a list of appearances, when this is setting the model appearance singular.
Oh, it's just a language issue.
Yeah, it's just wrong UX, okay? That's all. And so the goal is to get it right. I think that's the right thing to do there. Okay, so let's just go through these. So this is on any system model, you're saying there's the same attached cell. Is that correct?
Yeah, and the design is, and the implementation also is like image image mesh graphics, they all have toolbars like this.
I know.
So
I know that. I know that. I mean, I mean, yes, obviously we know that, but they're not quite exactly the same as that,
Yeah.
are they? So what we're trying to do is make sure we actually have a design.
Did you want random image?
I did. Thank you. Okay, here we go. Okay, so there's selection tool. Okay. All right. So why does it say model appearances? That says selection tool singular because it is a tool. And I guess this then says selection tools, which is a bit confusing. Okay. Model information. Okay. Somebody didn't follow the capital letter convention. Has anybody looked at this other than me? Roger? Did
Yeah,
you
I've
look
looked at it, but it's been sort of fluid. So
Okay. Well, fix the capital letters
Okay.
to agree with this. Make
Right.
sense?
mhm,
Yep.
And make these singular,
okay.
right? I don't know what model conversion, okay. So let's go through what
so
these are.
yeah,
The
let's
first
do
one
that.
is the appearance.
Right. And the reason that we have this very detailed thing is horrible if you have, like, say, if that was 100 by 100 matrix or have huge formulas
I
in it.
get the point. I get the point.
Okay.
But why is this one, that icon? I don't understand why that icon, which looks like it's a bunch of little vectors, has to do with the original full version. Do you understand
Okay.
what I'm saying?
Do you want a different icon for it?
Well, yes, we do. Because
Okay.
why does that icon mean what you say it means here?
Yeah,
I
no,
don't
no,
understand why
fair.
any of these icons mean
It's a
what-
fair point. Okay.
they just don't seem right.
Okay.
None of them seem right, honestly.
Mhm.
Is Tim here? Did Tim look at these icons?
Yeah, I suggested these. Yeah, Tim created these, but I
Was
So
Tim in
what's
this
your
meeting? Can we
suggestion?
get Tim?
Yeah, I'm right here.
Yeah,
I'm right
yeah,
here.
Okay. Okay.
yeah, I worked with Tim on this, so
Yeah, it's
so
hard to
I-
tell what they are at that small, though.
It's very
So,
hard to tell. It's
yeah.
like impossible. Like I couldn't see those with check marks.
And those
they were
top
little-
ones are too large. The gray ones.
Well, the gray ones I think are the size that they are for an image, aren't they? Maybe they're a little bit bigger.
They looked a bit bigger. They're filling the
they look a
space
bit
more.
bigger.
Yeah.
Okay. So they come down in size. But so let's understand what these icons are for. One of them is a general appearance icon. Do we have any other attached cells that have general appearance icons?
Mesh.
mesh
Mesh region.
Okay.
go
Can
to
I
mesh
make
region.
a mesh?
Go to mesh region. Otherwise, you won't be able to create one. And then just pick an example from there. Something a little bit more complex. Yeah, you could do that. That's pretty trivial, but yeah.
Yeah, it won't work in the documentation.
It won't
Little
work in it. Yeah, but pick it up and then.
I
and-
know.
Okay.
Well, why doesn't it work?
You'll need to
there?
evaluate it probably.
It's weird.
Now click it.
Okay.
That first one.
Mesh themes. Mesh decoration. Okay. So is this going to be called is this themes or what is this?
The
Or is
reason
this
it's used
appearance?
appearances is because the option that we're using to change it, like in the code, is
Yes.
appearance.
Okay.
That's why
All right.
I use
Okay.
the word
Okay.
appearance.
Okay. So this probably should be called. I
In the
guess
case of
chemical-
mesh, there isn't one sort of appearance. It's a lot of, it's a lot of options. And so it's themed,
Yeah,
where
I
you set.
understand.
Okay.
Display appearance or something.
Yeah.
I don't like calling it model appearance because.
No, I think that's fine. Display appearance is probably the better word.
All right, fine. So that could be display appearance.
Yeah.
Well,
Now, let me explain what that is. So
Yep.
this is conversion. So if you have a state space model, you can convert that to a transfer function model. And you can also convert a transfer function model to a state space model.
Okay.
Okay. And you can do things like you can make it it's sort of a more complicated function. What's like an affine state space
How
model.
do I get it back to what I originally had? Is it this one here?
Yeah, yeah. So that's I don't know the feature bug, but this is a thing that we cannot go back to the original thing
Why?
because the state space thing is not unique. So when it converts, the round trip doesn't land at the same place. So if you just wrap transfer function model around that and state space model around, if you keep composing functions like that, we will get back to the original state space model.
You will not get back.
You will
No.
not get back.
Right. Go ahead. I mean,
Yeah.
Okay.
So the issue is that
so in this structure, we're not storing the original.
no.
Yeah, I tried to, but it's not. Yeah, because this code is based on, yeah, we cannot in the current
Okay,
infrastructure.
Whatever. But do we? Oh. Let's see. I mean, how do we get these things out? Is there a click to copy here? No, there isn't.
Yeah,
I
it
don't
only
understand. Why isn't there a click to copy here?
Yeah, so that was the other. So yeah, that's the other thing I wanted to clarify. So we can get click to copy in for everything. Do you wanted a click to copy for everything or just because in every one of those features we could have a click to copy?
Well, what we should have here is the click to copy here should give the code necessary to generate this matrix. The click to copy of the matrix should give the matrix. Does that make sense?
Okay.
Yeah?
Yeah.
Okay, so
And these measure, this tells you something of the behavior,
do we have a function called singular value like that?
singular value plot.
Do we have a step plot?
No,
We have
a special case of output response.
So I don't understand why this says, I mean, like singular value looks like a function name there. I doubt it's a function name. It probably should just say singular value in 2 words.
Okay.
Do you agree?
Maybe it should have a tooltip that says it's a singular value plot.
Because this is a MIMO system, that's why we singular value. If it's single input, single output, that would be a Bodhi. So I just say the function is Bodhi plot, so I just wrote Bodhi, and for singular value plot, I just truncated
Well,
the
I'm
plot.
sorry, I don't understand. I don't understand. Where does it say Bodhi plot?
For a SISO system, it will say Bodhi plot. For a single input, single
So
output.
what does it say? Does it say Bodhi here?
Yeah, Bodhi.
Okay. Well, I don't know this field well enough. Roger, you have to say.
Well, I mean, it would be longer, but to say Bodhi plot and Nyquist plot, and the first one is an impulse response, the second one is a step response, and it could be more verbose, or at least there should be a tooltip that says what it is.
Yes,
because
no, I understand.
below that it's there.
Well,
What?
it says magnitude of singular values. It says response to unit impulse inputs. Why does it say inputs? It's input.
Because it's you give it an impulse as input, and now you see what the output
I know.
is.
Why is it plural? Input.
Because it has
plural.
2 inputs. This is multi-input system.
And that's why there are 2 curves, or what?
There are 2 curves because there are 2 outputs as well. So if you look at that model on top, that D matrix on the right has 2 columns. That's why there are 2 inputs. And
okay, let's try and get the iconography straightened out. Okay. Appearance. What should the icon be for that? I mean, what we could do is something which is a matrix and then a slash and then some other kind of thing that is well, they're all matrices, a matrix or a block diagram. So what I'm suggesting is that we take something like this, and then we put in there, then we put sort of a slash. I mean, I'm drawing this very badly. You see what I'm saying? and then something like this, obviously very small, but something where it's kind of half the square is taken up with those things, and you slice halfway through them, and the other half is some a block diagram piece. Did that make any sense, Jeremy, Tim?
You would have to
Anybody?
take out the interior of that block.
No. Do you want me to draw this? I'll draw this. Okay. Where is our canvas? There it
I
is.
think it can work if you take out the interior of that block. No text.
So what I'm suggesting
Yeah,
is,
it has to be abstracted. Very
yeah,
simple.
obviously.
Yeah.
I mean, I'm just suggesting that it is something which looks like this, and then the top is triangularized. Get what I'm saying? Something like that, where it's that or this. Does that make sense?
Yep.
Okay. I don't know who's actually going to do this. Is this?
I assume Tim, but I can help if needed, Tim.
I think Tim gets this. Yeah. Okay. So that's that first one. Makes sense?
Yeah.
Okay. The second one, model conversions. Well, actually, we've got to have the actual icons here.
Yeah.
And there, I'm just completely mystified by what you should do here. This is elided values, right?
Yeah.
So
Well,
I
mean,
think,
the third one uses elision. There's a lot of
no, I
the
understand. but
second
this
one
is
is
a grid.
structure.
This is a grid. So this first one, I think, should be larger, should be an array with larger elements in the array. The second one should be an array, but there are pure dots at every element.
Hmm.
Do you get what I'm saying?
Sure.
Yeah.
And the
that's a good
third
idea.
one, I would suggest, could be a whatever the appearance was for the elements here, but then the appearance of the elements, but then something where you have element. I would just maybe have an element there, a dot, dot, dot diagonal across, and maybe elements in the two corners. See what I'm saying? Whatever element you're using there. Did that make sense? Shall I draw it? Did you understand what I was saying, or do I need
I think it's fairly close to what's there that you're asking for, but to modify it a little bit.
Well,
If
I'm
you just-
suggesting that we do this. Suggesting that we have a whatever the blob is for an actual thing, an actual thing, an actual thing, an actual thing, and then a dot, dot, dot like that.
Okay.
So I'm saying, whereas the other one, you would have, instead of that, you would have something like, you would have for this other one, you would have, that for the very first one, you would have this. Right? With better drawn things. For the second one, you're putting dots in place of these things.
Okay.
Does that make sense?
Yep.
Smaller dots. Then this one, and then the final one, the final one, that diagram seems okay to me, pretty much. I mean, clean it up a bit, but it seems okay to me. Does that make sense to everybody?
Yep.
What about just adding the labels instead of tooltips? I don't think it hurts, and there's room.
Do it.
Yeah, same for these others. I don't think we need to skimp on labels like these. Yeah.
Fine.
Well, we might have to wrap those.
I don't understand these icons. I mean, the transfer function model where it just says, I mean, that's not one function. It's an array of functions, right?
That's what a transfer function is.
Well,
for
I
us
know that. I know
in
that.
our
But
design.
the fact that you say just G here, and then the second one has, this is super confusing. I mean, the second one is going to be numbers. So use the same iconography as you're using for that one there. Does that make sense?
Sure.
But it's important to have those the delimiter lines because they separate inputs from outputs.
Okay,
So
but the fact
upper
that
left block is the state, the sort of the dynamics of the system.
Okay, but what is this one? Why
So
is that?
yeah, that's showing the parameterization of the different. So I think if you see that because the state space model is parameterized by 4
Okay,
matrices.
can I clarify what's going on here? Okay, in this first case, we've got symbolic expressions. In the second case, we have just numbers. Is that a true statement?
Yeah,
It's
unless
a-
you have
It's
parameters.
a list of four matrices.
Well, do you have parameters? Is that a real
Sometimes.
thing?
Sometimes.
Yes.
But
Yes.
you have more parameters. In this case, everything is symbolic, right?
Yes.
Okay, so I would recommend for the second case, use the iconography from the array of numbers. And the third case, you seem to have some, I mean, is this typical that you have some things are symbolic and some things are numbers?
Everything is symbolic here.
Okay, but the symbolic form is different from the symbolic form for the first case.
Yes.
Because how is it different? I mean, so I'm just suggesting in terms of iconography that we copy
the last
number.
3 ones are state space forms. Okay, that means that you have a system state, you have input, and you have outputs. Now, the kinds of things, the very first one only accept linear constant coefficient systems. The second one can be affine in the inputs.
Maybe
but it
we
can be
need block
nonlinear.
diagrams for these.
But they're not.
Okay, but these icons don't make it. These icons are completely obscure. Having
Okay,
a single G
maybe
for
just
something which
text
is in
then.
it. Well, then that will be okay. I mean, if that's what works, then that's okay. Now, what are we going to do for model properties for the icon? Tell me what this.
I think what I would want to see is a step response. Just a simple curve that showed a step response. Oh no, it's not that one.
That's simulations. Yeah, this one
Okay,
is like
so fine. So then, but this
No,
one here,
it's
just
measurements.
a hamburger-like thing. Okay, just a series of lines
oh,
that
that's probably okay.
right that indicate you're going to get textual data, basically.
But then the next
This
one should
one
be
here,
just
yeah.
a step response.
Right. It should not be a sine wave. It should be something
No.
that looks like it was boom.
Right, exactly. That's a step response.
And
That would be impulse response, what you just said, but I think it
Yes,
should be
I
a
know.
step response.
Okay, fine. What does that sound like?
Well, it's like when you step on
know.
the gas of a car and you see sort of when it approaches that
Are you
target.
sure it shouldn't be an impulse response? It just seems like it would be better
Yes.
to use iconography.
No, step response is the
Okay, all right, fine,
you know.
fine. Okay, and then we got the last one here. Okay, and then this.
So again, so do you want that singular value split or?
Roger has
Yeah.
to say, I don't know.
Maybe singular values. Yeah.
Yeah, okay, fine. Oh boy. So what are we looking at here? Oh, are we getting galleries? Yes, good. Where are those galleries?
Okay. These are properties that you can get out when you do those designs that explains how things are wired up.
Are we happy with the visuals of these? They look kind of clunky to me.
They're okay.
Not
They're probably
terrible.
not the best.
They just look big to me. They don't look bad.
Okay, but so what's the gallery side of it is part of documentation, yes?
Yeah, we'll show this in documentation, but
It's useful
I
for
made
design.
it a gallery for you here, so you can see
I see,
everything that
I
you can
see.
get out in different scenarios. If you see.
Okay, so the second argument then is
Yeah.
look, you don't camel case unless there's a function with that name.
There is a property.
With that name. Okay, fine.
So this is part of the workflow. Yeah, that function is already designed. When you see where block diagram is, that's how we get a property. And now
No,
block
I'm not asking about that. I'm asking about the tooltips here. Feedback
Yeah.
gains model. The fact that that's camel cased is because there's a property that has that specific camel cased form.
Yes.
True or not true?
Yes,
True.
true. So then the user can see that and ask for that.
That's fine.
It's guiding the user in the design.
Okay. What should I be looking at here? You said this was going to be, I'm kind of,
Yeah, okay, so this
I
is
have to
like a
go in 8
workflow.
minutes. So Roger, we had a whole nother thing we were going to look at. Right?
Yeah, so we're probably going to have to schedule one more meeting then, unfortunately.
Yeah.
I thought that this would be faster because we'd already been here, but maybe we hadn't been here enough.
Okay. Anyway, you were saying down here.
Yeah, you're a little more down. Yeah, so this is all the properties that you can get.
This has also been now redesigned to be able to use information.
Okay.
Yeah, so you
Okay.
can ask for
In addition
information.
to this, the
Yeah.
Yes.
sub value.
Mhm.
Yeah.
Okay. All right. What else should we be looking at here?
There's one more thing, which is scroll up just a tad. Stop. Which is said simulation input. So let's say you designed a system and you want to see how it responds, like it's maybe just the initial plant model or it's the fully controlled system. You still want to see how it reacts to different inputs. Now, before you couldn't, you had to generate a list of inputs like random variant of that or
But we had input output response before, right?
yeah.
Yeah. It's just that
But
now
it just didn't accept a lot of these, inputs. You can directly give a
Why is
distribution.
this not giving me a raft? There's some bug here. There's some bug associated with this, I think. This didn't come up with the raft thing immediately. Am I making sense?
Okay.
So that's not for you, but that's probably for Natalia to report that bug.
Yes.
And all of these things that are listed here that are now accepted as inputs that can drive simulations it's just pure optimization. Just makes it, avoids a bunch of lines of code.
Okay. Yeah.
Otherwise, this is like giving white noise, normally distributed white noise.
But normally this is just giving a 1 there. What's the
A 1 means a unit step.
units.
a Dirac delta means what it
Impulse.
obviously means. But why these things are all of t, but yet that thing isn't of t?
Exactly.
Yeah.
Because
So
you can,
how can that be right? I mean, isn't it, shouldn't it be, I mean, that's going to fail, right?
yeah.
But this, yet here, it's expecting something which is a function to be applied to t.
But this thing is always from 0 on, right? So that means it's 1 from 0 on, like a unit step. You could have
I
typed in
understand that. The point that I'm making is this
Yes.
thing here, if I write something like, I don't know what, if I write, t squared or something, that's a function of t. See what
Absolutely.
I'm saying?
Mhm.
Right? But if you give a distribution like normal distribution, it's not a function of t.
Oh shit, that's not gonna, I mean, it's gonna work, but it's gonna give a symbolic solution because you have parameters in there.
Well,
It did work, okay?
yeah,
But it's gonna give a formula.
Yeah, I get it. But my point, Roger, is this, okay? The thing that is in here is something which is evaluated for t equals 0, t equals 0.1, t equals 0.2, and so on.
Right,
This normal distribution thing is not the same kind of thing.
right. It's not. But if it was a time series, it would be the same kind of thing because that has a value for each t.
I get it. I get it. So how do you get away with saying this distribution, which doesn't have a sub-value?
Well, we
can
could
be put in
avoid
there?
distributions and just say accept random
This is not
processes.
obviously wrong. I'm just pointing out, well, maybe there is a random process way to do this.
Well, not quite, because what you do is you have to do random function and you get temporal data.
Yeah, that's a mess.
Okay.
All right, so I'm flagging that I don't think this is quite right. Because
Well, I'm a little nervous about this too, because you have to actually say how quickly it, changes. What's the resolution, basically?
yeah, because it's infinite. A normal distribution, it's infinitely fine in t.
Right. And
you give it that way.
and the random processes sort of characterizes that. But
Yeah.
for a discrete time system, this is not an issue because that's just sampled at discrete time slots. Then it's just fine. See what I'm saying?
I
If you
think this
sample
requires
something
a
at,
tiny bit more thought. Yeah, I get what you're saying, but
Yeah.
you still previously that thing there
Mhm.
is an f that is applied to successive t values, even in the discrete case. In the discrete case, it's f of 1, f of 2, f of 3, I assume. Whereas in
Yes.
the continuous case, it's
Yeah, but you can give in the discrete case, We've always sort of accepted a
see,
list
allowed
is a perfectly fine sequence.
I think this requires a tiny bit more thought.
Yeah. I think
don't
that the other ones
disagree,
here
yeah.
are very fine, but this one is a little bit questionable for the continuous time system. For discrete time system, not a question. For continuous time system, not
Well,
sure
I
what
mean,
it means.
discrete time system, it's some kind of random variate, and then there's how many you want to give, isn't it? I mean, isn't the correct thing for a discrete time system something like random variate of this, comma 10 or something?
Yeah,
Yeah,
exactly.
yeah.
But the
that
T
code became-
indicates how many.
Yeah, I get
Yeah.
it, but it's a little weird that, I mean, let's say I wanted a constant there, and the evaluation is weird because this thing, I don't know. No, that's not right.
I mean, it does something special for distribution and processes and time series, etc., because those are ways to represent signals.
Yes.
So it interprets those inputs specially.
Yeah, we wanted to create that syntactic sugar for that case that you gave above. That's why we just give the normal distribution and then it samples every instant. It gets a random variate of so many things. And
Yeah, I
similarly
understand.
in the above case, we assume a sampling period of 1, and then we sample and then create an interpolating function. Because earlier when we were like simulating, we did that manually, and now that part we automate. So it makes our code a little more succinct.
Well, I don't have a strong opinion here. I mean, Roger, just make sure it is sensible.
Yeah, but we need to say, like we do, like so for instance, for data plotting functions or list plotting functions, what we say is like, if you give us an association, this is how we interpret it. If you give us a time series, this is how we interpret it.
Yeah.
So we give an interpretation, and we could do exactly the same here. We have a table and say, if you give us this, this is the interpretation. If you don't like that,
right.
explicitly generate your data, and it will work just fine.
Yeah, that's fine.
Yeah.
I think that's consistent
All right.
with everything else we've done.
I need to go. So I guess we need a second one of these scheduled.
Right.
All right. Hold
Okay.
on a second. Actually, just 1 second. Great. Okay. See
Thank you.
soon. Okay. Bye.